Hey guys, and welcome back to a new video here in this Navigation3 playlist. In this video, we will actually dive into creating a bottom navigation with multiple backstacks. Just like all the other videos in this playlist, this will be for both native Android as well as for Compose multi-platform. So depending on what you want to get better at or implement what you learn in this video, you can follow through this video regardless of what you want to get better at. Really, 95% of the code will be the same no matter where you apply it. And those 5% that are different, then in that case, I will mention that and specifically what would be different. To give you an idea of what we'll build in this video, here we will have a simple bottom nav screen with 3 destinations. Here, first of all, a to-dos list destination. We will have a to-dos favorite destination where we'll also just have some sample to-do entries, and we have a settings screen where we can see settings. And the idea of having multiple backstacks now, especially together with a bottom navigation element here, is that every single destination is to be seen as a so-called top-level destination, and that every single destination also has its own backstack. So this means if we go to to-dos here, and we, for example, visit one of those to-dos details, let's say to-do 11, then we get to the to-do details screen here, to-do 11, and then, well, in this example, we will have 5 more buttons to visit certain possibly related to-dos, to-do 0 to to-do 4. You could imagine this is some kind of product screen in an e-commerce app where you then also see some related products. And that means from this product screen or from this to-do screen, you can again get to another to-do detail screen. So here, for example, to-do 4. Then from to-do 4, we can get to to-do 2. And the actual backstack now is managed just for this to-dos destination. The moment we go to favorites, we will keep this backstack in mind for the to-dos destination, but when being on favorites, we again have a completely different and isolated backstack. So here we can again navigate to to-do 8, for example, and we could be on settings where we then see just the settings backstack. Here in this case, we will just have a single screen because the first 2 destinations will showcase this well enough. But the magic is now that when going back, we restore this backstack. So here on the to-dos list, we will actually directly get to our detail screen and we don't navigate to the base destination for our to-do list here. Same thing for favorites. If we click here, we get to the lastly visited to-do from our favorite screen. If we go back here from the favorite screen, here you can see there's also predictive back. We get back to the favorites list. If we now get back, we actually get back to our to-do screen and to the last visited screen there until we really popped every single screen here, and then our app will simply exit, and that is another app. And the same thing here in our Compose multi-platform project will of course also work that way here on iOS, that we have different destinations, to do 6 and to do 9, as you can see, but I don't think I need to show you this again. In order to implement this, I'm actually here on the base branch from the first video in this playlist where we've implemented our very first navigation setup here with our to-do list and to-do detail screen. In case you haven't watched that video and you don't have this code, down below you'll find a link to clone this initial code from the GitHub repository. But this is now the code that we want to adjust to supporting multiple backstacks together with the bottom navigation. And I would say that's also what we start with to define the composable that represents our bottom navigation bar. I would say we put this under our navigation package and we say we call this a to-do navigation bar. We make this a file, composable, to-do navigation bar, and we can first of all think about what kinds of parameters this to-do navigation bar actually needs from us in order to properly display the items that we can select, so our bottom nav items. Well, on the one hand, we need to know which key is selected, and a little refresher here, a key in Navigation3, a nav key specifically, is really nothing else than a specific screen we can visit. So since our bottom navigation bar here really just has 3 destinations and these so-called top-level destinations, so on the one hand to-do list, favorites, and settings. Those are our 3 top-level destinations, and one of these, when being in this section of the app, must always be selected, and that selected destination is our selected key. We can of course also select another key here in our bottom navigation bar when actually clicking on one of these options. So we can say on select key, or yeah, let's call it on select key. We pass in the nav key that we've clicked on, so one of these 3 destinations, and then in here we can define our bottom app bar. That is the composable to represent a bottom navigation view. There is also, I think, a navigation bar nowadays, which you could also use. Not sure if they will deprecate the bottom app bar at some point, but in case they do, you can also use this navigation bar. I'm actually not sure which is preferred here. I will just stick to the bottom app bar. That is what I'm used to. And then we can first of all forward our modifier here from this to-do navigation bar and see what else we may need here. Actually, we don't need a lot. Of course, if you would want to style this a little bit differently, you could pass more. But most importantly, inside this Lambda block, we now have the option to add actually a navigation bar item, because we are in this bottom app bar scope. This is what we now not only want to do once, but for every single destination that we could possibly visit, for every single top level destination. So for to-dos list, for favorites and settings. Let's actually keep this in a separate map, specifically to keep the information for each destination here also in a little bundled data class that we know which specific icon and title belongs together. And then we have a list of those items. So under navigation, we will create a new class called bottom nav item data class. We may want to make this or give this an icon in form of an image vector and a title, which will really be for displaying the text below this icon. And then we can actually have a val for our top level destination. So kind of a hard-coded map that we will have here that maps each top level destination, so each key in the end, to-do list, favorites and settings, to the corresponding bottom nav item instance. So this means from our routes that we already defined in the previous video, here where we currently have to-do list and to-do detail, we still lack the settings screen. So let's maybe extend this here. So we have a data object settings. Since it doesn't take any parameters, we can make this a data object, which will be both a route and a nav key. And the nav key actually isn't technically necessary here. Someone also highlighted that in the previous video. So we can also remove these here for the child instances because the route is already implementing the nav key interface. That will do it. This settings will be serializable, so we can treat this as a normal nav key route. And in our bottom nav item KT file, we can then say route dot to-do list. That is our first destination. And we map this to another specific item, specifically a bottom nav item instance, where the icon, let's put this on a separate class, separate line maybe, the icon is equal to icons, for which we need a dependency. You can also import these items here in Android Studio. For me, this is sadly super buggy in the recent Android Studio version, and I always have issues with the cache, but this is nowadays recommended to go to resources, drawable, new, vector asset, and then clicking on this clip art, you can import a specific icon. Well, now it worked, maybe because I've updated Android Studio, but I had cache issues that only the first page was always loading here. But I will just add the material icons dependency for simplicity here. In build.gradle, we can simply duplicate one of these compose UI dependencies and call this compose.material icons extended. If you're in a native Android project, then this will be a little bit different. Then you need to look up the specific definition for the material icons extended dependency for native Android, and therefore add this to your normal dependencies block in your Gradle file. For Compose multi-platform, it looks like this. And once the Gradle sync is finished, we can go back to bottom nav item, and now we can Alt-Enter import this icons dependency here, and then we can reference the outlined icons, specifically the checklist one for the first item, and the title here can be to-dos. We can then have a comma and define two more such destinations, specifically all those we want to appear in our bottom nav. Here, this will be our favorites. Our favorites we also don't yet have. So let's go to route, duplicate our to-do list, and call this to-do favorites, because that will also just be a data object. It will contain the same screen as for the to-do list, since it displays nothing else than that. But the difference is that we display just favorites. In our case, it will look identically, but just that you see that we could have multiple options here. So route to-do favorites here in our bottom nav item. This will be the favorite icon, and we call the title favorites. For the last item, this will be our settings route, specifically with the settings icon and the settings text. So this is now our top level destinations map, where we just map each destination, each specific nav key to the corresponding bottom nav metadata. The approach that I will actually choose here for the bottom nav and the multiple backstacks actually comes from Google's Nav3 recipes repository, but I personally found this quite hard to understand initially and not so intuitive, which is why I think it makes sense to explain this in a bit more detail. So let's now go to our to-do navigation bar, which should now depend on this top-level destinations, specifically to actually add such a navigation bar item for every single top-level destination we have. So top-level destinations, and we say keys, so every single route inside this map, we want to iterate over, so we say for each, we get each nav key, or each, let's call it top-level destination, and for each of those, we now want to have a navigation bar item, which will have the advantage that we would just need to extend this map with one more entry if we would want to extend this a bottom nav with another destination we can visit. We need to pass whether this item is selected. So we will see this, okay, if it's selected, it will be highlighted here a little bit. And this will be selected if this top level destination is actually exactly the selected key we've passed to this to-do navigation bar composable. When then actually clicking this, that means we want to select our key. Then we can have a lambda where we say on select key, and we want to select specifically the top level destination we've clicked on. The icon will be a composable. So we can say that is an icon that takes in an image vector, which will be nothing else than the top level. Let's actually get the data here. Well, actually we can just iterate over the map as a whole and then say we destructure this here to have the top level destination and the corresponding data for it. So this will be our bottom nav item data class, and this will remain our route. So here we could then say we take our icon from the data class, and content description can just be the title for that corresponding destination. We can then have a label, I think it's called, label, which will really just be a text that displays our title again. And that should already be it to display those 3 different destinations with our to-do navigation bar. That means we can now go to our navigation route, because what I want to do inside here is I want to nest this nav display inside a scaffold. Since a scaffold is in the end the typical layout in material design that lets us place these typical material design navigation-like composables like a bottom navigation at exactly the right position here at the bottom, and also consider the correct spacings for it. So we're going to have a scaffold where we get that inner padding, so the actual padding we need to apply after having placed this bottom bar to the main content so it doesn't get overlapped by the bottom bar. Inside the scaffold's function parameters, we want to have a bottom bar composable in which we really now just have our to-do navigation bar. So this is now the composable that displays here at the bottom. The selected key, well, that will be our current route that we are on. That's something we can't yet implement because we did not yet implement the navigation logic behind these destinations. So let's just hardcode this for now to our to-do list route on select key. Here we also can't yet do anything. Let's just add a to-do statement here, select key. And other than that, I think that is what we need to pass here. But let's now move our nav display into this scaffold. And here for this modifier, we pass to this nav display. This modifier actually now needs to be forwarded to the scaffold as the root composable. And our nav display will then get a fresh modifier. We say fill max size, and we consider this inner padding here. So this will just make sure that our nav display's content will be exactly this dimensions here, excluding the nav bar space. Let's also define our entry provider here. In the last video, I've already showed you an alternative approach to style this and create this without relying on these many indentations with nav entries. We could simply say we have an entry provider block here where we in the end don't get the key reference, but we can have these entry blocks that are in the end the same as such a nav entry composable, where we can say, okay, we have a certain entry for our to-do list route, and the same is the case for our, I think, 3 other destinations. We have to-do favorites, to-do detail, and lastly, we have our settings route. So for every single destination, we have such an entry now, and we say we take this to-do list screen, cut this out, move this into to-do list and favorites, because these look identical, but still get their own entry here. So they have their own backstack instance, their own top-level destination. To-do detail is what we have inside here. So we can cut this out, move this in here. We can replace this key with it, since this also comes here from this entry to get the parameters that we pass to the screen. And the settings screen is not yet implemented. Let's just make this a plain box composable that fills the screen and says settings. Something very simple. So modifier fill max size, and we make sure that we center the content with content alignment, alignment.center. And inside this box, we just have a text saying settings, something like that. Okay, so this is now our nav display definition. We've defined all of our routes here that we could possibly visit in this app, and we've defined our scaffold with a navigation bar. But of course, this navigation logic behind, specifically the logic for the multiple backstacks, that is missing. The first thing we want to do is we want to go to our navigation package and define a new class called Navigation State. This will be not a data class, but a normal class. And it will in the end be a class that now contains our entire navigation state. Because now, when thinking about it, we can't just rely on the simple backstack anymore that we get from remember backstack, Because in the end, every single top-level destination now needs to maintain their own backstack. But we still somehow need to contain or maintain the entire context of our bottom navigation bar. So when having visited one screen and we go to another screen, we still need the context that if from favorites we go back that we get back to the first destination, which is also considered the home destination. That is, by the way, a UX best practice here when working with a bottom navigation bar, that when a specific destination that is not the home destination, so either favorites or settings here, when we go back there, that we should always get to the very first destination, so to our home destination. And that is how this is implemented here. So even if we have some kind of stack here on our to-dos checklist or to-dos list, and we go to favorites, have something in here as well, go to settings. Now going back should not go back to favorites, which would technically be the last visited screen, but it should go back to to-dos, since that is a separate top-level destination, considered as the home destination, so always the first tab here in all of our categories, and that is what happens here, so we get back to our to-dos list. And to just maintain all that information, we want this navigation state class, which tracks what we need to track. Specifically, we want to know a specific start route, which is nothing else than a nav key. So that is our very initial screen in our bottom navigation view. So in our entire scene after all, so our to-do list in our case, we will have a top level route, which is a mutable state, so a compose state of nav key. This is in the end a state that updates when we navigate somewhere and always keeps one of these top level routes. So this can either be to-dos, favorites, or settings in form of our route instance, so we know which current bottom nav tab we are currently in. Then what we need is backstacks, because as the name says, we now have multiple backstacks, specifically one for every single bottom tab. And this will be a map that maps our nav keys, so the top level destinations, to a nav backstack of type nav key. So for every single top level destination, we have a key, so either to-do list, favorites, or settings. And when accessing this map at one of these top-level destination keys, we get the corresponding backstack for that top-level destination. So, for example, all the backstack entries for our to-dos list stack with all the other to-do detail screens we have currently visited and which are active on our backstack. We can then say val stacks in use, which is a list of nav key, so the specific backstack that are currently in use, but this is not exactly our entire backstack, which I think is one of the more confusing parts here in this example from the recipes, but I'll explain this in a moment. When we use the getter here and we override it and we say if top level route, for which we actually need a definition inside here by saying var top level route by top level route, Alt enter here to import set value and Alt enter to import the get value. This looks a little bit weird, I know, with this by top level route. In the end, what this delegate means here is we have our mutable state where we would normally need to reference the specific value, the specific nav key of that state with top level route.value. And if you would want to change that value, you would also need to say top level route.value is equal to something new. Now with this by keyword here, this is really nothing else than using this somewhere here to define a state with remember, by remember, mutable state of something. Then we can also import this delegate, so we can directly get the state as a plain primitive integer property without having this wrapper of a mutable state around it, which is just a bit more convenient. So in this example here, we just get our nav key directly while still having the advantages of a mutable state so that it's observable. So inside this if statement, we just want to check if the top level route is equal to our start route. So if we are currently here in our home destination in our to-do list, because in that case, the stack we want to return here is just the start route, and otherwise it is our start route and our top level route. This is in the end a data structure that we really just use in order to implement this UX best practice that I've just talked about, that if we are here on our to-do list screen and we navigate somewhere, that navigating back from a non-home destination always leads us back to our home destination. And this is what this check does here. So if we are on that home destination already, well, then our backstack will just, or top level destination, will really just be that home destination. If we are not on that home destination, then we will construct a backstack that consists of the home destination. So this is where we can navigate back to. And the current destination is the current top-level route, so either favorites or settings in this case. And this is the confusing part here, I think, because it's not so intuitive that what we construct here, these stacks in use, they are not our entire backstacks. Those are in the end just our top-level destinations that we can visit. But in each top-level destination, we will have our own nav backstack that can then contain, for example, our to-do detail screens and as many of them as we want. Now that we have this class, we can go down here and create a little composable function that helps us to actually get an instance of this class, because obviously we now need this navigation state in our composables in order to reference it and know which destination we're currently on. So we can create a composable function here called remember navigation state, which will take our start route in form of a nav key, and it takes our current, not our current, but our top level routes, all those that we could visit, in form of a set of nav keys, and which will then give us a navigation state reference. Now, one very important thing that we need to consider here in Compose is that if we have such a, let's call it a random state of nav key here, that we need to make sure that it is properly persisted. So that means that it, on the one hand, survives configuration changes on the Android side. So when we rotate our device, that our state is not lost, which is usually also possible to do via a view model. But we also have the thing that process death could happen at any time on Android when our app is in the background. So if the system is hungry for memory, it could decide to kill our app. And if our app is killed and the user goes back to it via the recently used apps tab, then that top-level destination would be lost unless we properly persist it and restore it. How does that work? Well, we can say the current top-level route is equal to remember serializable, which is a composable function that also comes from the Nav3 library, which in the end helps us to persist such a serializable value. Since all of our routes are serializable, that is the function to use here. We want to make sure that here for these inputs and these keys, we pass our start route and our top level route. So whenever these change in any way, then this remember serializable block will be executed again. And then we need to pass a configuration, which is really nothing else than what we've already defined here in this saved state configuration. This is one thing that is really just necessary in Compose multi-platform, but not in native Android. In native Android, you simply won't be prompted to pass this configuration. But in our case, we can really copy-paste the previous saved state configuration, paste this in here, and we just need to extend this with our two other new classes to do favorites here and here, as well as settings. So just all the destinations you could visit. Furthermore, here below this configuration, we need to pass a serializer, which is a mutable state serializer. So this is now, in the end, the class responsible for serializing the specific piece of data we want to serialize here, so our nav key. And since our nav key, our top-level destination here, is stored in form of a mutable state, we need a mutable state serializer. Then this mutable state serializer takes in a K serializer, for which we can pass a polymorphic serializer of type nav key class. So thanks to the serializers module, we've defined which subclasses we want to be able to serialize, and that is therefore a polymorphic serializer, what we pass in here, and that whole thing will be stored in a mutable state reference, so that is read in a mutable state. Then we can open a block of code, because now we lastly need to define what should be serialized, which is our top-level destination, or actually the start route, not the top-level destination, which we can then place in a mutable state of start route. And then we don't have any more errors here to get the top-level route. So this is just the initial value, but the actual top-level route here, that is something that can be changed. Since, as you can see, we have a mutable state of nav key, so of either to-do list, favorites, or settings. And since that is a mutable state, we can of course change it afterwards the moment we navigate. But initially, this top-level route is our start route. Okay, next up, we want to construct our backstacks. So this map here that maps each top-level destination to their own backstack. This is luckily easier than what we've defined here, since for that we already have a ready-made function from Nav3 that we can use that takes care of the serialization work. So we can have our backstacks where we say we have all of our top-level routes, plural here, our set of all the nav keys inside our bottom nav, to-do list, favorites, and settings. And we want to say associate by, which will construct a map. Sorry, it's actually associate with, which will construct a map where we get each key, so each specific top-level route, to-do list, favorites, and settings. And we want to map these keys to remember nav backstack. So to the same composable function we've already used here to get a normal instance of the backstack, but we now do this for every single top-level route. So every single top-level route in our bottom navigation view gets their own backstack from this function. And since this function already takes care of the serialization work, we don't need to do this here on our own. Here we again need to pass in this configuration. So I would suggest we actually put this in a separate property. So we cut out this safe state configuration, maybe have a val here, and we say serializers config, and we paste this in, and then we can reference this in both these fields here and here. And we then also need to give this remember nav backstack function initial route that should be shown when visiting a specific top-level destination. And well, that will just be the top-level destination itself. So when going to favorites, the very first screen that should show here is actually the favorites list screen, or to do favorite screen as we've called it. When visiting settings, the very first screen that should show up, unless we already have a backstack, should be our settings screen. So this is simply what we can pass here, just whatever key we're iterating over here from these three options. And this gives us exactly the type of map we care about, which maps each top-level destination to the corresponding backstack. And with all these pieces of information, we can now return remember while passing in some keys, specifically the start route and the top-level route. So whenever these change, we will reevaluate this remember block, and we can construct a navigation state with what we've defined so far. Start route is our start route, top-level route is top-level route, and the backstacks is this backstacks map that we've defined here, and we don't have any more errors. Now the last function we need is a function that takes an instance of this navigation state and in the end maps it to the right navigation entries. So the right entries we have here in our entry provider, since we in fact won't actually construct it like that here. This was just to demonstrate which screens we need, but we will actually use a different overload of nav display. Here, if we type this nav display, you can see there is an overload that takes in a list of nav entries, and we will have a function that takes this navigation state and converts it to the corresponding nav entries. So this will be an extension function, navigation state, to entries, will also be a composable function. And inside here, we need to provide this entry provider. So we can still make use of this, what was defined before. It will just be defined in a little bit different way. This entry provider will give us a nav key instance, so for the current destination we've visited, and it will return a nav entry of type nav key. And this whole thing will return a snapshot state list, so in the end a list of compose states that contains nav entries of nav keys. So nav entry, as you've seen before, is really nothing else than a specific composable destination that we can navigate to, and these destinations we place in a snapshot state list, so we just say these could change, and Compose would need to be notified about these changes. Now, when returning such nav entries in form of a list, we also already need to define the specific decorators we want to add there. So a little reminder, here with the nav display, we have the option to pass these decorators, which in the end just extend the behavior of a specific nav display or of a specific nav entry in our case. For example, that we can properly restore states and that we can properly scope view models here to this destination. That is what we now want to construct, so val decorated entries. And for that we use our backstacks coming from this navigation state we extend. We want to map the values, so we take all the values inside this map here in our backstacks, map these are the values. So in the end we iterate over all the different backstacks that we have here in this backstacks map, and those we get here, each specific stack, and we map each stack to its decorators, which are also just a list of these nav decorators. So exactly the ones that we've used here, just a normal list of, we can paste this in here. This one actually needs the nav key passed explicitly here, but then we don't have any more issues. And then with this list of decorators, we can return remember nav, what is it called? Remember decorated nav entries. There's also a function that already comes from nav3, and it takes our entries, our backstack that we're iterating over here, so the current stack. It takes these entry decorators in form of our decorators, and it takes the entry provider we pass here just normally into this function. This must come from the outside, so exactly this definition is then what we will pass in there to define which screens we can visit. This here is giving us an error. Argument type mismatch, actual type is map entry. Map value should actually give us a backstack, but it gives us a map entry. probably because it gives us both these. Let's say we don't care about the key. Is it then? Yeah, now it's a nav backstack and that works. So we just don't care about the key, just care about the values. And then for every single backstack that we have here, so 3 backstacks in total, we will create such a remember decorated nav entries. So specifically, just a list of nav entries where each single nav entry is now one real destination inside one of our destinations. So a single to-do detail screen, for example, here would be a separate nav entry, another one, and so on. Well, each top-level destination now has its own backstack. Now, with these decorated entries, we can return stacks in use. So remember, that is the property that we have inside our navigation state, which is either just a list of our start route. So if we are here in the to-do list, then just that to-do list will be returned. Or if we are on another destination, then we will return that other destination on the top of our backstack and our start route, so our home route here, after all, as the previous destination where we would get to when navigating back. We then want to say stacks in use, so this will return a list of nav key. And we want to flat map these, where we now get each specific nav key of our top-level stacks in use, so either just the to-do list or the to-do list together with either favorites or either the settings, but not all 3 together. And we would now say we access decorated entries at exactly that key. If that doesn't exist, we return an empty list with no destinations at all, and we convert this whole thing to a mutable state list, so something that Compose can observe. I know this is maybe seeming confusing, so let's go over this again. What happens here in this toEntries function? We first of all define these decorated entries. I think this is what is really the clearest here in this function. We take a look at every single backstack we have, so the backstack for to-do list, the backstack for favorites, and the settings backstack. And we really just add those 2 decorators, so we make sure that every single screen, whether it's the top-level screen or one of these detail screens here, is able to get its own view model scope to it, is able to properly save and restore state we may have in it. And then for every single top-level destination here in our bottom bar, we get a list of nav entries, so a list of all the destinations that we have visited in that particular bottom tab already. And now the thing is that we could either be here on our to-do list, where if at some point we navigate back until we are really at the to-do list. When does that happen? At some point here, we are at the to-do list. Now when navigating back, we actually need to know whether the app should close, like here, or if we are possibly at a different destination, be it favorites or settings. When navigating back here, we don't want the app to close, but to navigate back to the start route, because that is just the UX best practice, as I've mentioned. So you can really think of this stacks in use here as our global stack that is just allowed to contain the top-level navigation keys, either to-do list, favorites, or settings. And either we are already at the start route, then that global stack will just contain the start route, and therefore navigating back will close the app. Or if we are not, then this global stack will just contain the start route together with the current route we're on, so either favorites or settings. And that is what we do here. So we flat map this list here so that we get a reference to each element in this stacks in use list, so each nav key. And for every single nav key, we get the corresponding entry from our decorated entries list that we've constructed here. It's actually a map. And then say, okay, keep this observable. I think it's very worth making this video, even though this is contained in Google's recipes, because this stuff is really confusing. I also didn't grasp it initially, but it is, when thinking about it, quite a scalable approach here. And once having understood this once, you can also just copy paste this in other projects and use this immediately. So the last thing remaining for this video is really just to create a nav display while making use of what we've defined, specifically now taking this entries list of nav entries. For that, we first of all need our navigation state, which is luckily now pretty easy. So we can clear this backstack. We won't need this anymore, but we can get a navigation state here from our remember navigation state function, which will actually need a start route. This will be our route to-do list, so the very first route to visit. And the top-level routes will come from our top-level destinations map, specifically just the keys. And this is now our navigation state instance that we can use in order to get a reference to the current navigation state for our whole bottom nav setup. All right, so inside here, nav display, we now want to link our entries, which we get from this navigation state .toEntries, so a little function that we've created here. We want to use this overload that simply has normal parentheses with this entry provider. And this is now the place where we copy paste our entry provider here with all of our nav entries. So our code is happy. We just don't yet have a backstack that we can add these routes to, not yet. But let's ignore this problem for now and see what else we need here. We actually need to pass a modifier to properly consider these window insets from our inner padding. So fill max size, padding, inner padding. And lastly, for this particular overload of the nav display, we also need this go back or on back lambda, which tells us what should happen when we navigate back. And then you can see this overload will resolve. We can remove this bottom nav display here. So the last missing piece here is really now just a little class that helps us to navigate, which will actually also change the state inside this navigation state class. This will be a Navigator class, and don't worry, this will be a rather simple class inside our navigation package called Navigator. Make this a normal class, which will take in an instance of our navigation state, since it needs to reference that, of course, in order to change our top-level route somehow. And in here, we can now have a navigate function where we can say we want to navigate to a specific nav key, so a specific other route. And in here, we first of all want to check if this route that we want to navigate to is actually in our but in our navigation state .backstacks.keys. Remember, these keys are really nothing else than all the different top-level destinations. So in our case, to-do list, favorite, settings. Because that means if we want to navigate to one of these destinations, to-do list, favorites, or settings, in that case, we just want to update our navigation, our navigation state top-level route to the new route. For example, favorites, in order to navigate to this new favorites top-level destination. But if our route that we want to navigate to is not inside these keys, so in our case, it would be the to-do detail screen, which is not a top-level destination, then, so in the else block, we want to find out which current backstack we are actually working with. So the backstack for the current top-level destination, and we say navigation state backstacks at the key of the route, of the current top-level route that we're on, so navigation state, top-level route. This will now give us the backstack for the current top-level route, for the favorite screen, for example. And this backstack, we now want to push this route to on top of it. So we say if that exists, we add an element, specifically this route. And this is how we navigate here. We then also need a function to go back for the back navigation. Here we also need to first of all find out the current backstack. So val current stack is state. Let me rename this to just state. I'm always typing state while it's called navigation state. So states dot, what is that, backstacks, while referencing the key of the current top-level route. That is our stack that we want to work with. We can make a null check here. So in case this is null, then it would be due to our invalid setup here. So we can say error, putting this on a separate line perhaps. Let's call it backstack for state dot top-level route doesn't exist. So this will crash our app since we try to go back from a destination that is not a top-level destination. Then we can say val current route, so the specific screen we are on inside the top-level destination, which could be our to-do detail screen, and that's equal to our current stack that lasts, so whatever element is on top of our stack. And if this current route is equal to state top-level route, so this means we are on favorites, and the current route is also the favorites list screen. Then we want to say that our state after navigating back, so the top-level route, is now equal to the start route because of our best practice that we want to implement here, so that when we go back here, then we get back to our start route exactly like that. And if that's not the case, so if our current route is not the top-level destination, so we're maybe on favorites and we are on to-do detail, which is not the top-level destination, then navigating back should simply pop this last visited screen here, so our to-do detail screen, from the backstack, particularly from the favorites category. So we can say we take this current stack and we just remove the last entry or null. So this is in the end the same as pop backstack. And now with this class, we can go to navigation root, create a Navigator instance, which is equal to remember Navigator, and we pass in our navigation state here that we've created above. And that is now our little helper class we can use to, on the one hand, go back. So we can say Navigator go back. And when clicking on a specific to-do, we want to navigate to our to-do detail screen with this to-do that we've clicked on. So we can say navigator.navigate to route to-do detail here and here. And that should be it. Let me take a look at where this navigation root is used here in app. because yes, I recall that we had a scaffold here already. We can move this out and simply don't care about this inner padding because we now already care about that inside the navigation route here with our scaffold. So we don't need to do this outside. Okay. Here on select key is of course something we still need to implement. Here we also want to say navigator.navigate, and we want to navigate to the current top level destination that we get as a reference here. So whenever we click on a destination, we want to navigate to this destination, of course. So we delegate this to our navigator, and the selected key will be our navigation state dot top level route, because that's our state that keeps a reference to which specific top level route we are currently visiting. And when that changes, we of course also want to change the bottom bar selected item. Okay, that was a lot and that was tough, I think. But that's how this works. Let's run this and give this a shot, see if this works, if this looks reasonably as what I have here. And there we go, our app launched successfully. We are here on our to-do list screen. If we are on here, okay, we can't yet click on other buttons here to visit further to-dos, which I think is also not necessary in order to demonstrate this. But we are on to-do 39. And if we now go to favorites, we get to our favorites list. Okay, here we can go to, let's say, to-do 50, go to settings, we get to settings. And if we now navigate back, what we would expect is that we get back to our to-dos list with item 39 being open. And that's what happens. Here's 39, going back once more, will give us our normal to-do list. And when going back to favorites, our backstack for that one is also restored so that we still see our to-do 50. Again, navigating back here, you can see, will lead us also to our to-do list. So that's exactly the behavior that we wanted here, which is very, very common when you have a bottom navigation bar. I know this was super complex, so let's maybe go through this once more as a little recap. In the end, we have this bottom bar, which is nothing else than this composable, having 3 different destinations, which references this top-level destinations map. We have really nothing else than a map that maps each specific destination we want to have as part of our bottom navigation to just the metadata here, so we can easily iterate over this map to add another element. That is what we do here in this bottom bar, and whenever we select a specific item in this bottom bar, we get the new route that we want to navigate to, so either to-do list, favorites, or settings. And then we created this navigation state class, which is in the end just a class that contains the entire navigation state for the entire feature after all, or the entire bottom bar section in this case, which keeps reference of the start route, so the very first route that we've visited, the current top level route, so which bottom bar category we're currently on, and all the backstacks. So 3 backstacks for every single destination in this case, with all the routes, with all the actual nav keys that we've visited for each specific tab inside this bottom navigation bar. We just created a remember navigation state function. This is solely responsible for actually creating an instance here and making sure that this instance is also properly serialized and persisted so that it would survive process death on Android, that it properly survives screen rotations and normal configuration changes, and our navigation stack is not lost. And we have this toEntries function, which takes this navigation state instance we've created previously, additionally takes this entry provider, which defines which specific nav key, so which specific route should look how, so how the composable after all looks like, and it returns snapshot state list, so a compose state list of nav entries of specifically visitable destinations. These are now all the destinations we could visit in this context, together with these decorators with this little extra behavior of being able to persist values. And then depending on where we are, we want to return a different, let's call it global stack, that either allows us to not navigate back like here, so the app would close, or when we are not on the main screen, that we can navigate back to our main screen. And this whole thing is then wired together by this Navigator class, which just changes the internal state of our navigation state, so we can use this here in navigation route to navigate somewhere in our app with go back, with navigate, and so on, after having defined this entry provider. So that's how this works. This is a lot of work, I know. This is very complex. And while Android or Kotlin multi-platform development is very complex, it doesn't have to be complex for you. Since luckily you have the option to work with me and my team one-on-one in our mentorship program, where we really work together on a daily basis to work on your exact technical struggles, where you build a real industry scale app and then get code reviews for every single line of code, where we can then pinpoint every single little issue even the smallest ones, so you can work on these in order to really become an industry-ready Android developer or Kotlin multi-platform developer, get the job you want or advance in your current job. Whatever your goal is, down below you'll find a link to apply there. We really keep this rather close and only work together with people here where this really fits. But if this is generally something that sounds cool to you, then take a look at the description, apply. And other than that, thanks so much for watching this video. I will see you back in the next one. This Navigation 3 playlist is not yet over, but we will have many, many more concepts to cover. And these next concepts will also rather get less complex. Cool. Thanks so much. Bye-bye. See you back next video.